Hello and welcome back to Math Class in Session. Today, properties of exponential functions. A function of the form y equals b to the x is called an exponential function because the x is in the exponent. It's called an exponential function. We note that x is in the exponent while b can vary. B could be any positive number. It can't be negative, but it's kind of meaningless if b is the number 1, because then we have y equals 1 to the x, and that's just the line y equals 1. So we'll take a look at these functions when b takes on positive numbers other than 1. Suppose b was the number 2. That's what we have here in front of us, y equals 2 to the x. I've laid out some x values, and let's fill in the y values. And then we'll have a table of values, and we'll put it on a grid. Suppose x was 0. Well, if we sub in 0 upstairs here, 2 to the 0, we know is the number 1. And if we sub in a 1, 2 to the 1, we know is the number 2. And if we sub in a 2, well, 2 to the 2 is 2 squared, and we know that to be 4. While if we sub in a 3, 2 to the 3 is 2 times 2 times 2, and that's 8. Suppose we tried some negative numbers. Let's take 2 to the minus 1. Subbing in minus 1 up here for x, we have 2 to the minus 1 is 1 over 2. While if we tried minus 2 up here, 2 to the minus 2 is 1 over 2 to the 2. 1 over 2 squared, and that's 1 over 4. Let's put these on a grid. 0, 1 goes to 0, 1, right there. 1, 2 goes to, well, 1, 2, right there. 2, 4 goes to 2, 4, right there. 3, 8 goes to 3, 8, up there. Negative 1 1/2, well, it's negative 1, and then a halfway to 1. Negative 2 1/4, well, that's negative 2, and a halfway to a half, which is a quarter. Join them all together, and let's label this y equals 2 to the x. Now we note that b is greater than 1. Here b is 2. Let's make some notes about the case when b is greater than 1. We see that there's an asymptote on the left. The x-axis is an asymptote. This line is getting closer and closer to the x-axis, and that's what an asymptote is. And the equation of the asymptote is y equals 0, and we say this phrase as x approaches negative infinity, which is on the left. So we can see it approaching here. We see that this graph is increasing. Increasing means as we proceed to the right, it's getting higher and higher and higher. It's going up, going up, going up. So if b is greater than 1, we have a graph that is increasing. And through the y-intercept 0, 1. Well, anything to the 0 is 1, so I would think that whether the base is greater than 1 or less than 1, anything to the 0 is 1. In fact, that is the grand meeting place of all the parent functions that are exponential functions. So the graph is increasing through the y-intercept at 0, 1. There it is right there. I put that on a computer, and we have y equals 2 to the x according to a computer. But I also did y equals 3 to the x, and we can see the difference here. Y equals 3 to the x just goes up more steeply. It has the same basic shape, but it goes up more steeply, but it still goes through 0, 1, and it still has an asymptote on the left. Same with any base greater than 1. Y equals 10 to the x. It's just more pronounced. It's going up more steeply, and it's coming down more steeply towards its asymptote on the left, which is still the x-axis, and it still goes through 0, 1. And so we have all of these different exponential functions. And each one of them could be a parent function for some transformations. Summarizing, if b is greater than 1, the graph is increasing, the y-intercept is 1, The domain is x is any real because x can be any number far to the left or even far to the right. We can sub in any number here and say 10 to the x, 10 to the negative, 10 to the large positive, 10 to anything can be subbed in there. So the domain is x is any real, while the range we can see from the graph is y is greater than 0 because all of these functions are above the x-axis. That's why we say the range is y is greater than 0. Let's consider a case when the b value is less than 1, but it doesn't make any sense that it ever be negative. So it will be between 0 and 1. 1/2 is a good starting point. So let's consider the parent function y equals 1/2 to the x. If x is 0, subbing in 0, anything to the 0 is 1. If x is 1, anything to the 1 is itself. So 1/2 to the 1 is 1/2. Subbing in 2, 1/2 squared is 1/2 times 1/2, that's a quarter. Now subbing in some negative numbers. Subbing in -1 upstairs here for x, we know the effect of that is to invert the base. So 1/2 becomes the number 2. If I subbed in -2 up here for x, we see that, yes, it inverts the base, but then squares it. So it inverts it to 2 and then squares it to 4. And if I subbed in a -3 upstairs here, again it inverts it, but then cubes it. So 2 times 2 times 2 is this 8. Graphing these points, 0, 1, the grand meeting place. 1/2. Well, let's go to 1 and up 1/2. How about 2/4? Let's go to 2 and up halfway to 1/2, a quarter. -1, 2, let's go to -1 and rise to 2. -2, 4, to the origin here, slide over 2 to -2 and go up to 4. And -3, 8, go to the origin here, slide over to the left 3 and go all the way up to 8. Join them together, put a label on it, y equals 1/2 x. Now let's take some notes when the base is less than 1. When b is less than 1. What have we got? Let's observe. We see an asymptote, which is the x-axis, y equals 0, as x approaches infinity, as x gets large, positive infinity this time, so it's on the right. We see that the graph is decreasing, meaning if I get on the graph here, and as x goes to the right, the y value is getting lower, 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 and it keeps doing that all the way to infinity. The graph is decreasing through the y-intercept, which is still 0, 1. Now I've put them all together. 1, 2 to the x, 3 to the x, 10 to the x. Now I've added 1/2 to the x, and we can see how different it is. The reason being that b is less than the number 1. Here b is 2, b is 3, b is 10. Now b is 1/2, and we see that its fundamental shape has changed. So if b is less than 1, what can we observe? The graph is decreasing. The y-intercept is still 1. The domain is still x is any real number because we can take 1/2 and apply any real exponent to it, negatives, positives. The range is still greater than 0. All of these y values are above the x-axis, so greater than 0. And that's a summary of the parent functions that we're calling the exponential functions.